All right, in today's screencast, we're looking at electron orbitals and diagrams. A lot of this is based on the work of Niels Bohr, who was a Nobel laureate or a physicist, and it's on his work you kind of figure out, hey, there are orbitals, and this is how they're structured. And Bohr's name is spelled B-O-H-R. So if you catch the joke, good for you. Anyways, so the periodic table we'll start using now more and more because we'll start understanding why it's structured the way it's structured. Remember from last time we talked about the different names of orbitals S, P, D, and F. And if you look at this diagram, you see, hey, there's S, P, D, and F. In fact, they're labeled with their sublevels, 1s, 2s, 3s, 2p, and forward. And this tells us a lot about different atoms and why they behave the way they do, and eventually gives a shortcut to knowing what their outer electrons are. First, we're going to learn how to determine their whole orbital electron, then we'll realize, hey, we know a shortcut without even trying. All right, electron configuration. This is a way of writing out the electron configuration of atoms, so where its electrons are for an element. All right, so the first one is we're going to write out orbital sublevels, and there's a really easy way to do this, and I'm going to show you right now how to do this the short way without the rack our brains and memorizing more than we need to. This is the electron configuration. Remember last time we talked about each level has its own sublevels, and if you've been reading your book closely, this is nothing new. All right, so we have our different, remember, first orbit level has only one sublevel, S. Second level has 2s and 2p, 3s, 3p, 3d. All right, so the first step when you're doing electron configuration, if it asks for it, is to write out this. It'll make your life so much easier than trying to memorize it. Come on, there we are. All right, second step is determine the number of electrons. If it's a neutral atom, it's the same as the atomic number. We're not worried about the number of neutrons for the isotopes because that's not matter. So we're just gonna look and say, are we talking about an element or an ion? Right, ions have gained or lost an electron. We'll talk more about those in the next lesson. All right, then we would call how many electrons fit in each orbital. Remember, S fits 2, P fits 6, D fits 10, F fits 14. And we will go over this in class, but I want to have a chance to see it in print from your textbook, from me in this lecture, and then we'll do it again in person just to practice, make sure we got this idea down. All right, and then we draw diagonal lines counting the electrons. So let's run an example of this so far. Let's do boron. Boron has an atomic number of 5. It's the 5th element, so we know it has 5 protons and 5 electrons. We're not worried about the number of neutrons. It does not affect its elemental identity or its electron configuration. All right, so that's our first step then. Has 5 electrons. So we start drawing diagonal lines, right? So the first one, let me get to my pointer. Remember, boron has 5 electrons. In the first orbital, we have 1s, fits 2 electrons. Right. Second orbital starts off with 2s, so 2 electrons fit here in 2s. So we have 2 electrons here in 1s, 2 and 2s, which will count for 4 electrons so far. And the next one, we draw diagonal down, starts at 2p. 2p can fit 6 electrons, but boron only has 5 electrons. So boron has 1 electron in the 2p sublevel. So we write this all out then. So boron's electron configuration is 1s2, 2s2, 2p1. Remember, because we have 2 electrons in 1s, 2 electrons in 2s, and 1 electron in 2p. And we will do some bigger examples in person, but I like to keep these screencasts short. But it's the same exact pattern for every single element and every extra electron configuration. And soon in class we'll talk about a shortcut way. Just use a periodic table to figure out the electron configuration. That works most of the time, but with larger elements it gets a little bit trickier. And that shows up in your reading with the exceptions. But this table here will help us find those exceptions for the most part. All right, so I think that's all we needed to cover. So next up, we'll do the octet rule, which helps determine how an element is likely to react. All right, please see me with questions. We will practice this in class and see why it's useful, but please make sure you've done the reading closely and try to do the self-check to the best of your ability. All right, if you have questions, please see me on the floor or in class or shoot me an email. All right, I'll see you guys for the octet rule next.